AI agents used to feel like a secret club. A highly exclusive club meant only for elite programmers.
Oh, absolutely. It was completely fenced off for the average person.
Right, but that barrier to entry has completely vanished. Suddenly, anyone can build one without writing a single line of code. Welcome to today's deep dive.
We've got a really great one for you today.
We are exploring the fascinating world of no-code AI agents. Our mission today is to completely demystify this technology for you. We are using a brilliant, comprehensive guide as our map.
Yeah, and we're actually going to learn how to build a custom personal assistant together.
A digital assistant that will check your calendar. It will evaluate the local weather. It will even pick a running trail and email you a daily plan.
And we are using a visual platform called N8N for this build. It lets you treat complex automation like digital Lego blocks.
You definitely do not need a computer science degree to do this. You just need a bit of patience and the right steps.
The accessibility of this technology is completely shifting the landscape. People hear the word agent and they immediately feel intimidated. But it really is just a tool you can control entirely.
Okay, let's unpack this core concept first. We need to look at the robot versus the thinker.
Right. Standard automations have been around for a very long time now.
So what is the core difference between simple automation and an AI agent?
This is a crucial distinction we need to make right away. Simple automation is exactly like a basic light switch. You flip that switch and the light comes on.
It follows a very straight, predetermined line every single time.
Exactly. A classic example is an automation sending weather data at 9 a.m. It cannot think or adapt to any new information. Old automation is basically a train stuck on a single track.
And if the track is blocked,
The entire train just crashes. It just blindly executes the same steps over and over.
that rigidity is exactly why standard automations fail when life gets messy. Which makes me wonder, how exactly does an agent get around that rigid limitation?
What's fascinating here is that an AI agent operates entirely differently. An agent is a thinker that can actually reason through problems.
You give an agent a goal instead of a list of steps.
Yes. If you ask it, should I go for a run today? It actually thinks. It evaluates your busy schedule and checks the local weather.
It might even check if the air quality is clean enough.
Right. And then it chooses its own path based on the current situation. If it is raining, it pivots and suggests an indoor treadmill workout.
So why does this flexibility actually matter so much for us?
Because real life simply does not happen in straight lines. Unexpected things happen every single day. Standard automation breaks easily.
But agents handle the unexpected.
They dynamically handle those unexpected surprises without giving up. They look at the tools available and figure out a solution. They mimic human problem solving by weighing different variables in real time.
So agents can reason and handle surprises that would completely break standard automations.
Perfectly said. The context of the moment dictates their next move seamlessly.
Let's look at the anatomy of an agent now. Every no-code agent relies on three foundational pillars to function.
The brain, the memory, and the tools.
It is funny when you strip away all the hype. An agent really just boils down to those three core parts.
You really cannot skip any of them if you want this to work. The brain is the obvious starting point for any build.
In AI, this is just a node where you plug in your model. You can choose OpenAI, Claude, Gemini, or whatever you prefer.
Let's define that term for clarity. An LLM is a smart text engine that plans and reasons like a human.
It acts as the central routing engine for your entire workflow.
It is less of a chatbot here and more of a project manager. You hand it your prompt, and it looks at the available tools. It figures out a logical sequence of actions to achieve your goal.
But a project manager is entirely useless if they have severe amnesia. Which brings us to the second pillar, memory.
It seems entirely obvious when you think about it.
But why is memory so often overlooked by beginners building these systems?
Context is everything for an intelligent and natural conversation. Imagine walking into your boss's office every single morning. Imagine having to reintroduce yourself from scratch every single time.
That would be a terribly frustrating experience.
Exactly. Without memory, your agent forgets everything after just a few seconds. We use short-term memory to remember the current chat session's flow.
And long-term memory to recall important data from the past.
Right. Memory keeps the agent completely focused on the actual task at hand.
Without memory, it's like meeting someone for the first time every single time.
And that completely ruins the illusion of a smart assistant.
The third pillar involves the tools, the agent's hands. The brain can think, but it cannot do the actual work alone.
Tools are the digital doors connecting your agent to everyday applications. We have red tools for gathering information, like checking Google Calendar.
We also have act tools for executing tasks, like sending Gmails.
Tools are what make the agent genuinely useful in reality. They let the AI reach out and touch your actual digital life.
Here's where it gets really interesting, though. We need to discuss how these tools actually connect.
Yeah, this is the magic behind the curtain.
How do these no-code systems practically talk to the outside world? Let's dive into the API vending machine concept from our source material.
You can imagine an API as an office vending machine. You don't need to understand the internal gears of that machine. You just need to know which button gives you your favorite snack.
Let's define this concept simply. An API is a digital door that lets two different software apps talk safely.
Right. When your agent presses the weather button, it gets the temperature. It does not need to know how the remote weather station works.
It just retrieves the exact JSON data it needs to keep functioning. I still wrestle with getting these API HTTP requests right myself, honestly.
It can definitely feel a bit overwhelming when you first look at the documentation.
The payloads and the headers can look like a foreign language initially. How do we actually choose between using a G, a T, and a POST request?
It is entirely about asking versus doing. A GATE request is basically just a very polite question. You are politely asking, what is the weather in Saigon right now?
The goal of GetT is simply to retrieve information back to your computer.
You are not changing anything on the server at all. A POST request, however, is much more like a direct command.
You use PokeT when you want to change something in the system.
Exactly. You use it to create a new calendar event or send an email.
GetT asks for data nicely. PPay gives an order to change the system.
If you understand that, you understand 90% of APIs. The API is the vending machine, and the functions are the buttons.
Okay, we are going to take a very quick break for our sponsor break.
Welcome back to our deep dive on no-code AI agents.
We are exploring how to build a custom running assistant today. We're using a specific platform called N8N for this project.
Which is such a powerful tool.
Why is N8N the perfect tool for building this Lego-style assistant?
Well, N8N has a visual canvas that changes the entire building experience. You are drawing a mind map instead of looking at boring code. Everything in this platform is displayed visually as individual nodes.
Let's clarify that term for our listeners. A node is a visual building block that performs one specific task.
Each box does one job, and lines connect them together. You can clearly watch how your data moves across the clean screen.
NNN also features a highly specialized AI agent node.
This is the ultimate control center for your entire automated system. It provides ready-made plugs for the brain, memory, and your tools.
You can swap your brain from OpenAI to Claude in mere seconds.
You do not have to rewrite hundreds of lines of routing logic.
Whoa, imagine scaling this to manage an entire business on autopilot. It feels like having a massive team of digital employees.
It is entirely possible, and the costs are surprisingly low. You can start with a free trial or run it locally forever. The cloud version gives you 1,000 runs a month, very affordably.
It keeps your agent awake and working while you are sound asleep. I want to push on this visual aspect a bit more.
Sure. Why do visual platforms beat writing code for beginners so decisively? What happens when a complex automation inevitably hits a wall?
A visual layout isolates any system errors immediately for you. If a specific box is broken, you see it instantly on screen.
A red light flashes on the exact node, causing the actual problem.
You do not have to hunt for a missing comma in raw Python.
Seeing the logic mapped out visually makes fixing broken parts instantly much easier.
It completely removes the guesswork that normally frustrates new programmers.
Let's actually walk through the build process from start to finish. Our guide breaks this down into 5 very actionable steps.
I want to spend some real time exploring each of these phases. Step 1 is setting up the trigger for your entire workflow.
You add a schedule node and set it for 5:00 a.m.
This acts as the daily alarm clock for your digital assistant. You are telling the system exactly when to wake up and start thinking.
A cron job is much more reliable than my own human alarm clock. Step 2 involves adding the brain to your workspace canvas.
You drag the AI agent node and connect it to your schedule. You paste your OpenAI API key and select the GPT-4 mini model.
Choosing that specific mini model is actually a very strategic move here. That model is incredibly fast and extremely cheap for daily personal tasks.
Latency matters a lot when your agent is chaining multiple actions together.
You do not need a massive, expensive model just to parse weather data. The mini model handles basic reasoning tasks with incredible efficiency and speed.
Step 3 is giving the agent its essential memory. You add the Postgres chat memory to the AI agent node.
Let's talk about why a persistent database matters for a daily habit. A daily running assistant needs to remember your past preferences perfectly.
If you hated a specific trail last Tuesday, it should remember that today.
Postgres provides a robust long-term database schema for this exact purpose. It ensures the agent stays focused during its complex morning routine.
It pulls your historical data and injects it right into the current prompt.
Now, step 4 is the really fun part, connecting the agent's tools. We are giving the brain some actual hands to interact with.
We connect Google Calendar to check when you are actually free today.
We connect Open Weather Map to see if it's raining outside right now. We connect a Google Sheet containing your favorite local running trails.
Finally, we connect your Gmail to send the final running plan.
The way the agent chains these standard tools together is fascinating. It checks your calendar first to find a suitable free time slot.
Then it checks the weather specifically for that available window of time.
If it is sunny, it pulls a trail from your Google Sheet. Finally, it drafts a highly personalized email and sends it directly to you.
It does all of this reasoning without any human intervention at all.
Step 5 introduces a slightly advanced, highly customized no-code skill.
We add a custom API tool using an HTTP request node. We are pulling specific air quality data directly from the AirNow database.
I get that custom APIs add some interesting flavor to the build.
But standard weather apps already tell you if it is sunny or raining. Is it really worth the extra effort to build a custom AirNow integration? What is the real value of the custom API over standard tools?
It moves your bot from being generic to being highly specialized. Standard tools are great, but custom APIs provide completely unique, hyper-local data.
Your assistant can now warn you if the air is dangerously dusty.
It can intelligently suggest that you run on a treadmill at home instead. A generic weather node simply cannot provide that level of nuanced health advice.
Custom HTTP nodes let you pull niche data from anywhere on the internet.
Custom APIs turn a basic generic bot into a uniquely smart, hyper-personalized assistant.
It elevates your project far beyond a standard, boring internet chatbot.
But we need to keep this intelligent agent safe and reliable. We must implement proper guardrails and understand basic system debugging.
If you give an AI tools, you also need to give it boundaries.
If you do not set rules, the AI can become dangerously overactive. It might try to do too much and make frustrating, cascading mistakes.
It might decide to email your entire contact list about your morning run.
We need to define this term for our listeners clearly. Guardrails are strict rules that keep your AI from making bad decisions.
Think of guardrails like the sturdy fences on a fast mountain highway. They keep your agent from crashing into a ditch unexpectedly.
You set these strict rules directly inside the main system message box. This is the master list of instructions the agent must always follow strictly.
It clearly tells the AI what it absolutely cannot ever do. You tell it to only email you and never email your boss.
That allows you to relax and actually trust the automated process.
But what happens when the system inevitably throws a red error message? People naturally assume that a red error means a catastrophic system failure.
They really do.
Why do people fear breaking the visual system so much?
They panic because they think they permanently broke the software logic. They see a JSON parsing error and assume they need a computer science degree.
But errors are simply the system trying to communicate a minor data mismatch.
Right. Two nodes are just having trouble understanding each other's data format right now. The weather node sent a number, but the email node expected text.
You do not need to read a boring technical manual to fix it.
You just take a screenshot of the error and paste it into ChatGPT. You ask it how to fix the error in your NNN visual workflow.
It will tell you exactly which box to click and what to change. It acts as your personal debugging tutor, available 24/7.
Errors aren't scary failures. They're just signposts showing you exactly what to fix.
They are fantastic learning opportunities that teach you how data actually moves. So what does this all mean for your future?
Once you master the brain, the memory, and the basic tools,
What are the truly exciting future possibilities we can build next?
the entire digital world truly becomes your personal automated playground. You can easily swap your trail list for a web search engine tool.
You can build a sophisticated research assistant in just a few short minutes.
You can ask it to summarize the daily Bitcoin news automatically every morning.
You could also build a highly responsive customer support bot. You connect it to your business email and a Google Sheet of FAQs.
It can answer complex customer queries accurately while you are sleeping. It reads the incoming email, checks the FAQ sheet, and drafts a polite response.
This raises an important question about scaling these concepts even further. We're talking about single agents doing specific tasks right now.
Sure.
What is the ultimate potential of these multi-agent systems working together?
Multi-agent systems let you build a completely digital, automated company. You can create one master agent that acts as a central project manager.
This manager can delegate specific tasks to other highly specialized sub-agents.
One agent handles deep internet research, while another agent handles the actual writing. A third agent might review the writing for tone and accuracy.
They talk to each other and collaborate without your direct input at all.
You are essentially building your own customized, automated digital workforce from the ground up.
You transition entirely from an individual worker to a high-level system manager.
Yeah.
Okay, let's take a moment to recap the big idea here.
Yeah, let's bring it all together.
Building your first no-code AI agent is exactly like learning to ride a bike. It feels very wobbly at first, and you might lose your balance occasionally.
You will probably fall over and see a red error message early on.
But you have tools like ChatGPT to help you get back up quickly. Once it finally clicks, it is an absolutely amazing, empowering feeling.
You transition from just passively using AI to actively building real solutions with it.
You are taking back control of your own digital environment completely.
I want to leave you with a provocative thought to consider today. We have spent this time discussing how to connect tools and databases together. If platforms like NEMN can do the heavy lifting of connecting complex systems,
What if the most important technical skill of the future isn't coding?
but simply knowing how to clearly ask for what you want?
That is a fascinating perspective to leave our listeners pondering today. The ability to define a problem clearly becomes your most valuable asset. We encourage you to just jump in and try this out yourself.
Do not worry about making your first personal agent completely perfect. Just try getting two simple nodes to talk to each other today.
Thank you so much for joining us on this deep dive. Out to your own music.